In section 1.2, we're starting to talk about something called functions. And a function is, as you can see here, I describe it as a set of instructions that gets you from an input value to an output value. So a function can be something as simple as saying, if you have a 1, you go to a 2. If you have a 2, you go to a 2. If you have a 3, you go to a 1. This could be considered a function. You know, your possible input values are 1, 2, and 3. Your possible output values are 1 and 2. There doesn't need to be any sort of relation between them. They don't have to be numbers. If your input value is red, your output value could be elephant. They don't have to be numbers. Usually, since we're dealing with a math class, usually we tend to deal with numbers as our functions, going from numbers to numbers. So with function notation, the function f of x, if you see something written like this with an f, for some reason I always switch to a fancy f, but it doesn't need to be a fancy f. I'm going to do it anyway. When you see an f of x like this, or when you see f and then the x in parentheses, this is not denoting multiplication. Normally you think of multiplication when you see numbers right next to parentheses, but this f is actually not a number. This is the name of a function. The name of this particular function is f. Just like we call variables x or y or z, we're calling the name of this function f. And this function, like I said, is a bunch of inputs, a bunch of instructions rather. And it's specifically telling us that whatever's on the inside of these parentheses is our input. So this value of x is going to tell us what our input value is, and whatever we get out of this is going to be our output. Alright, so let's just do a couple examples here, see if we can make sense of this. I said let f of x be negative 2x plus 3, and find the following. Well, let's find f of negative 3. If I say this right here, f of x equals negative 2x plus 3, you can look at this as kind of a recipe. If I tell you f of x, you can always replace it with negative 2x plus 3. And so specifically, if I tell you f of negative 3, then that negative 3 is just going to take the place of the x. We'll get negative 2 times negative 3 plus 3. And then we can just clean this up. That's 6 plus 3, which is 9. So that means f of negative 3 is equal to 9. Now you don't want to try to take this negative 3 outside of those parentheses. They can't move over those parentheses. They have to go through the function first. You have to evaluate the function is what we call it. F of t, again, this is the same sort of thing, only we're calling it t instead of calling it x now. So f of t would be negative 2t plus 3. You'll notice when I draw t's, I always draw a little bit of a tail on my t, because I don't want it to look like a plus sign. There's a couple other things that I do you'll probably pick up throughout the semester. Alright, if I want to figure out what f of x plus f of 3 is, you can say I'm actually calling the function f 2 separate times. First off, I'm calling it and feeding it a value of x, and we know f of x is just equal to negative 2x plus 3. F of 3 is, well, let's see, negative 2 times 3 plus 3. I'm calling my function again, but in this case, the 3 is taking the place of the x. I put both of these are both substitutions. Instead of writing f of x, I'm writing this stuff. Instead of writing f of 3, I'm writing that stuff. And whenever you do a substitution, it's always safe, it's always a good idea to kind of default to putting it in parentheses and then figure out if you can get rid of the parentheses afterward. These parentheses actually don't do anything, so I'm going to drop them immediately, but it's good if for no other reason you can kind of see this is the first thing that was evaluated, this was the second thing that was evaluated. Alright, so we get negative 2x plus 3 plus, negative 6 plus 3. Let's see, 3, and negative 6, those all cancel each other out. You get negative 2x. Alright, f of x plus 3. Let's figure that one out. Well, this is saying that I feed in an x plus 3 into this function. So wherever I saw an x up here, I need to put an x plus 3. And necessarily I'm going to have parentheses around that to make sure everything works out. So it's still that still looks like my negative 2 blob plus 3. This is negative 2 blob plus 3. only instead of blob, I'm saying x plus 3, and you can see I put it in parentheses to make sure that the order of operations works as expected. But of course, now that I have gotten rid of all my function notation, I can just use the order of operation, or I can use this distributive property, you know, all the normal properties that you're used to. So distribute my negative 2 through the parentheses, I get negative 2x minus 6 plus 3. This gives me negative 2x minus 3. All right, when we're talking about these functions, the independent variable is the variable that is the input, and the dependent variable is the output. Usually this ends up being x, this ends up being y. And you can see I said input, output, just to remind me what I was looking for when I formed this question. Input and output. So the reason I say this is because, like I said, these instructions go from the input to the output. We kind of say that this is our independent variable and this is our dependent variable. Like the there is this causation. The arrows are going that direction. You don't always have to have that one directionality from functions, but that's kind of how we introduce it, and that's how we start. All right. If we say y equals f of x equals mx plus b, this is just kind of a mouthful, but this is saying f of x is mx plus b, just like we set up above. Except there's one additional thing here. We're also saying that we're going to be calling that output of this function, we're going to be calling it y. For all intents and purposes, it's just a line. You don't even have to think of it as a graph, but it is, or as a function, but it is a function. All right, and moreover, it's called a linear function. Its graph is a line, and its slope of m, and a y-intercept of 0,